The Psychology of Money, Lesson 4, Confounding. Lessons from one field can often teach us something important about unrelated fields. Take the billion year history of ice ages and what they teach us about growing your money. Our scientific knowledge of Earth is younger than you might think. Understanding how the world works often involves drilling deep below its surface, something we have not been able to do until fairly recently. Isaac Newton calculated the movement of the stars hundreds of years before we understood some of the basics of our planet. It was not until the 19th century that scientists agreed that Earth had, on multiple occasions, been covered in ice. There was too much evidence to argue otherwise. All over the world sat fingerprints of a previously frozen world. Huge builders strewn in random locations, rock beds scraped down to thin layers. Evidence became clear that there had not been one ice age, but five distinct ones we could measure. The amount of energy needed to freeze the planet, melt it anew, and freeze it over yet again is staggering. What on earth literally could be causing these cycles? It must be the most powerful force on our planet, and it was just not in the way anyone expected. There were plenty of theories about why ice ages occurred. To account for their enormous geological influence, the theories are equally grand. The uplifting of mountain ranges, it was thought, may have shifted the Earth's wind enough to alter the climate. Others favored the idea ice was the natural state interrupted by massive volcanic eruption that warmed us up. But none of these theories could account for the cycle of ice ages. The growth of mountain ranges or some massive volcano may explain one ice age. It could not explain the cyclical repetition of five. In the early 90s, Serbian scientist named Milutin Milankovic studied the Earth's position relative to other planets and came up with the theory of ice ages that we now know is accurate. The gravitational pull of the sun and moon gently affect the earth's motion and tilt towards the sun. During parts of the cycle, which can last tens of the thousands of years, each of the earth's hemisphere gets a little more or a little less solar radiation than they are used to. And that is where the fun begins. Milankovic's theory initially assumed that a tilt of the Earth's hemispheres caused winters cold enough to turn the planet into ice, but a Russian meteorologist named Vladimir Koppen dug deeper into Milankovic's work and discovered a fascinating nuisance. Moderately cool summers, not cold winters, were the icy culprit. It begins with when a summer never gets warm enough to melt the previous winter's snow. The leftover ice base makes it easier for snow to accumulate the following winter, which increases the odds of snow sticking around in the following summer, which attracts even more accumulation the following winter. Actual snow reflects more of the sun's rays, which exacerbates cooling, which brings more snowfall, and on and on. Within a few hundred years, a seasonal snowpack grows into a continental ice sheet, and you are off to the races. The same thing happens in reverse. An orbital tilt letting more sunlight in melts more of the winter snowpack, which reflects less light the following years, which increases temperature, which prevents more snow the next year, and so on. That is the cycle. The amazing thing Here is how big something can grow from a relatively small changes in conditions. You start with a thin layer of snow left over from a cool summer that no one would think anything of, and then, in a geological blink of an eye, the entire earth is covered in a miles thick ice. As glaciologist Gwen Schultz put it, it is not necessarily the amount of snow that causes the ice sheet, but the fact that snow, however little, lasts. The big takeaway from the ice ages is that you don't need tremendous force to create tremendous results. If something compounds a little growth, serves as a fuel for future growth, a small starting base can lead to results so extraordinary they seem to defy logic. It can be so logic defying that you underestimate what's possible, where growth comes from, and what it can lead to. And so it is with money. More than 2,000 books are dedicated to how Warren Buffett built his fortune. Many of them are wonderful, but few pay enough attention to the simplest facts. Buffett's fortune is not due to just being a good investor, but being a good investor since he was literally a child. As I write this, Warren Buffett's net worth is $84.5 billion. Of that, $84.2 billion was accumulated after his 50th birthday. $81.5 billion came after he qualified for Social Security in his mid 60s. Warren Buffett is a phenomenal investor, but you miss a key point if you attach all of his success to investing acumen. The real key to this success is that he has been a phenomenal investor for three-quarters of a century. Had he started investing in his 30s and retired in his 60s, few people would have ever heard of him. Consider a little thought experiment. Buffett began serious investing when he was 10 years old. By the time he was 30, he had a net worth of $1 million or $9.3 million adjusted for inflation. What if he was a more normal person, spending his teens and 20s exploring the world and finding his passion? And by age 30, his net worth was, say, 25,000. And let's say he still went on to earn the extraordinary annual investment return he is being able to generate 22% annually, but quit investing and retired at age 60 to play golf and spend time with his grandkids. What would a rough estimate of his net worth be today? Not $84.5 billion, $11.9 million, 99.9% less than his actual net worth. Effectively, all of Warren Buffett's financial success can be tied to the financial base he built in his subsequent years. Longevity he maintained in his geriatric years. His skill is investing, but his secret is time. That is how compounding works. Think of this another way. Buffett is the richest investor of all time, but he is not actually the greatest, at least not when the measured by average annual returns. Jim Simmons, head of the hedge fund Renaissance Technologies, he compounded money at 66% annually since 1988. No one comes close to this record. As we just saw, Buffett has compounded at roughly 22% annually, a third as much. Simmons' net worth, as I write, is $21 billion. He is, and I know how ridiculous this sounds given the numbers we are dealing with, 70% less rich than Buffett. Why the difference if Simons is such a better investor? Because Simon did not find his investment stride until he was 50 years old. He's had less than half as many years to compound as Buffett. If James Simons had earned his 66% annual returns for the 70 years span Buffett has built his wealth, he would be worth, please hold your breath, 63 quintillion, 900 quadrillion, 781 trillion, 780 billion, 748,160,000 dollars. These are ridiculous, impractical numbers. The point is that what seems like small changes in growth assumptions can lead to ridiculous, impractical numbers, and so when we are studying why something got to become as powerful as it has, why an ice age formed, or why Warren Buffett is so rich, we often overlook the key drivers of success. I have heard many people say the first time they saw a compound interest table or one of those stories about how much more you had have for retirement if you began saving in your 20s versus your 30s changed their life, but it probably didn't. What it likely did was surprise them because the result intuitively didn't seem right. Linear thinking is so much more intuitive than exponential thinking. If I ask you to calculate 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8 in your head, you can do it in a few seconds. It's 72. If I ask you to calculate 8 into 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 8, your head will explode. It is 134,217,728. IBM made a 3.5 megabyte hard drive in the 1950s. By the 1960s, things were moving into a few dozen megabytes. By the 1970s, IBM Winchester drive held 70 megabytes. Then drives got exponentially smaller in size with more storage. A typical PC in the early 1990s has 200 to 500 megabytes, and then wham, things exploded. In 1999, Apple's iMac comes with a 6 gigabytes hard drive. In 2003, 120 gigs on the Power Mac. 2006, 250 gigs on the new iMac. 2011, first 4 terabyte hard drive. 2017, 60 terabyte hard drives. 2019, 100 terabytes hard drive. Put that all together, from 1950 to 1990 we gained 296 megabytes. From 1990 through today we gained 100 million megabytes. If you were a technology optimist in 1950s, you may have predicted that practical storage would become 1000 times larger, maybe 10,000 times larger. If you were swinging for the fences, you would have said 30 million times larger within my lifetime, but that's what happened. Counterintuitive nature of compounding leads even the smartest of us to overlook its power. In 2004, Bill Gates criticized the new Gmail, wondering why anyone would need a gigabyte of storage. Author Stephen Levy wrote, despite his currency with cutting edge technologies, his mentality was anchored in the old paradigm of storage being a commodity that must be conserved. You never get accustomed to how quickly things can grow. The danger here is that when compounding is not achieved, we often ignore its potential and focus on solving problems through other means, not because we are overthinking, but because we rarely stop to consider compounding potential. None of the 2000 books picking apart Buffett's success are titled The Guy Has Been Investing Consistently for three quarters of a century, but we know that's the key to the majority of his success. It's just hard to wrap your head around that math because it is not intuitive. There are books on economic cycles, trading strategies, and sector bets, but the most powerful and important book should be called Shut Up and Wait. It is just one page with a long term chart of economic growth. The practical takeaway is that the counterintuitiveness of compounding may be responsible for the majority of disappointing trades, bad strategies, and successful investing attempts. You can't blame people for devoting all their efforts in what they learn and what they do to trying to earn the highest investment returns. It intuitively seems like the best ways to get rich, but good investing is not necessarily about earning the highest returns because the highest returns tend to be one of his that can't be repeated. It's about earning pretty good returns that you can stick with and which can be repeated for the longest period of time. That's when compounding runs wild. The opposite of this, earning huge returns that can't be held on to, leads to some tragic stories. We will need the next chapter to tell them.